Is everyone here who wants to be here? Sound check? Is it? Okay. You going to start? Good evening, everyone. Welcome to the Port Elizabeth Amateur Radio Society monthly meeting. Guest speaker this evening is Tony, ZR2TX, and I will be giving a presentation on a messaging system called MeshCore. The note at the bottom. Okay, what is MeshCore? It's a multi-platform system enabling secure text-based communications utilizing LoRa radio hardware. MeshCore itself is the routing and the firmware. It's available free on GitHub, and anyone can download, adapt it, amend it, and utilize it for their own use. There is a cross-platform mobile app that is developed by a New Zealander, Liam Cottle, that operates on Android, iOS, and on a PC. Again, free to download. At this stage, that app is not open sourced, but he is very receptive to suggestions with regards to the development of that application. As MeshCore is open source, anyone is free to develop their own app to use with it. It operates on the 433, 868, or 915 megahertz open bands, if you like, depending on the region in the world that you are. And anyone can build anything they like to run on top of MeshCore free of charge. What do you need to get started using MeshCore? There are three types of devices that you have in the MeshCore ecosystem. One is your companion device, which purely links to your cell phone. It is not a repeater. It takes the messages from your cell phone via Bluetooth out into the mesh via a repeater and propagates it that way. Okay, so it connects to your cell phone using Bluetooth. There's also a PC-based app, which we'll see later, based on USB. It forwards messages to the mesh using a nearby repeater. It does not repeat itself. However, it can message peer-to-peer with nearby companion devices. It runs on a wide range of hardware, Rock, Heltec, LilyGo, just to be some of the more common examples. There's an ever-growing list of devices that are supported in the firmware, with many secondary developers coming on board to provide support for these devices. Repeater. As we mentioned, this is the second type of device that you get. It runs on the same hardware as a companion node, and they're interswitchable. You can flash a repeater onto the device as you need. The repeater just repeats. It does not do anything other than that. It's a fairly streamlined firmware that they run on the repeater, and it generally will repeat any packet that it receives that meets the criteria of the on. However, as I'll explain later, in a routing scenario, when you are routing a message, if the repeater is not in that routing path, it will ignore the packet. And the nice thing with the repeater is that it can be remotely managed over the mesh itself. So generally we find you can get up to 2 hops via one repeater to a second one and manage it remotely, which allows you to change the settings. Unfortunately, you can't update the firmware over the LoRa network. The bandwidth isn't sufficient, but you can administer it and make changes if necessary. And then you have the room server, which is essentially an old school BBS. It again runs on the same hardware with specific room server firmware, and it allows you to post messages there which can be retrieved later by individuals who might be off when that message is posted. Because if they are on the normal mesh message that goes out, if it's a general message or an individual message and they're not online, obviously they will miss that message. There's no storage anywhere for that other than in a room server. Flashing the firmware, very, very simple. There's a web-based flasher that you connect your device to via USB. You select the hardware type you have, and it will determine which firmware to use based on that, and you select flash, and away it goes and does the job. Very, very simple. Repeater devices that are based on the NRF52 chip, which is RARC and one or two other obscure boards, but generally the RARC boards, those can be flashed over Bluetooth. Very useful if you have a repeater up on a mast. You can stand at the bottom of the mast within Bluetooth range and update the firmware without having to climb the mast. So that makes it very useful. The underlying principles that I can pick up following the way they're developing this project is that the main focus is on reliable, dependable message delivery. That is what they want, is that it must serve the messages reliably and dependably and quickly. Any development that they add on, being telemetry, positioning, etc., must have minimal impact on that above principle. They're keeping the roles of the devices separate. As you see, there's a companion device, there's a repeater, a room node, and just yesterday, after I'd already done this, they brought out a fourth device, which is a sensor node. And that is specifically for people who are wanting to run sensors. That node will be configured just to deliver sensor data. So they keep those roles very, very independent, allowing for small, efficient firmware, and again, simple to maintain. Again, firmware is completely open source, free for personal or commercial use. The resources, the cell phone app is available on the Google Play Store and the Apple iStore, whatever they call it. There's a PC-based web app, which I will demo shortly. The main website is very informative with a lot of information and resources on it. The web-based flasher is available at that URL. They have a very active Discord group where you can interact with the developers, and they do listen to you and implement suggestions. And I'm quite proud to say that I had one of my suggestions implemented just recently. The app developer was only working in normal 12-hour format, AM, PM, and I requested that he include 24-hour format, and he's just confirmed that in the next release of the app, 24-hour format will be available. And then the GitHub site where you can actually access the firmware and adapt it and fiddle with the firmware if you want to on your own, the programming side. That's the presentation done. I'm going to now switch over to a live demo of the actual application itself and showing how it functions. If I can get out of this. How do I get my screen back? Oh, yes. Okay, so as we saw on the resources page, there was a link to app@meshcore.nz. That will bring you to this application. I just want to go back again, confirm. We'll go out of it, we'll go back in again. You'll be presented with that screen. I have a device which I cobbled together quickly, rack board with a Bluetooth and 433 megahertz antenna and a battery connected via USB cable. And you connect, and there's the device. Those are all the contacts that it has stored currently that it's received. There we have a message from someone. Werner, who's unfortunately unable to join us, is at home, but he's sending messages through just to give me something to play with. You'll see we have repeaters, and they're indicated by the repeater symbol. There's a message room that we have running, and then there are individual Eric, Werner, his wife. Not a lot of users at the moment, as we've been testing for quite some time, but we've got to a point now where we'd like to roll it out and have more people play around and join the group. FEDesk, that's Gabriel, not a club member, but Gabriel Fernandez, he's down in Summerstrand. So if I want to message Gabriel, I would click on there and I would just send down and you'll notice in the path it's saying flood. It's busy sending. Initially, when you make a contact with or send a message with MeshCore, it sends it out as a flood message, which means it will go to through every repeater until it gets to the destination. There will be an acknowledgement that will come back, and that acknowledgement will then track the path of the message on the way back. So once it gets back to me, having been received, okay, we've had a fail. We'll just give it a retry. It then has a path, and the second message will just follow that path. So all the other repeaters will ignore it. Hopefully we can get through to him, otherwise we'll try a simpler one. It's just I don't have a very good signal from this repeater that's sitting here on the table. Let's send one to my mobile. Okay, that will be a direct message, as in we're in the same location. So that won't really help. Let me find one that I can send. You send to Werner. I've also been struggling with him because this is not particularly good signal from you at the moment, so not very good for demo purposes. Again, you'll see it's still sending out flood because I haven't been able to establish a path yet. Once the path is established, then it's far more reliable. Okay, you can see it's a marginal signal because I've just received the message coming in from Werner. So we'll try again. Last attempt, and then we'll skip it. It's delivered. Okay, and now you'll see at the top we've got a path of one hop. We can now go and have a look at that path. And it has gone from this device straight to the Quebecer repeater, which is at Andrew's QTH and Taverna. So it's missing out this repeater completely. I don't know why, but okay. So basically that antenna did that. So it's a straight path. And now once we've got that path, we should find that messages will be much quicker.
How will it work if you download it on the iOS or on your phone?
Exactly the same. Hopefully it's going to send, not skip that. What you're seeing here is an exact mirror of what you'll find on your phone. So my phone will connect to that device and will send a message exactly the same. Sorry?
Bluetooth is scanning, no device is fine.
Well, you're not going to be able to get my device because I'm using it.
So
You need to have a device of your own.
okay.
So a device is linked to one phone, and only one phone can link to a device at a time. If I'm going to go into the similarities and differences between this and Meshtastic shortly, but those of you who've used Meshtastic, it's very much the same thing. In that sense of one-to-one linking. Okay, so you'll see that message went through a lot easier now that the path has been established. With repeaters, I can now manage that repeater that's sitting at my home down the road. And hopefully it's going to link. Nothing ever works when you... Yeah. I don't know why it's doing this. When I tested it earlier on this evening, everything was working fine. Let's do this. We know this one will work. Okay, that's a demo repeater that's sitting here doing nothing. You log into it. And you can get basic statistics of the repeater, battery voltages, what its clock is set at, how long it's been running for, and then some signal strength readings, as well as the noise floor that it's experiencing. Very good noise floor, minus 115 dB. And then details on the packets that it's forwarded, etc. You can then go into the settings screen, where from there you are able to... This is very much the same settings as you do with a companion device. Setting your name, it's got a public key. Now, this is where it's interesting. You'll see that this information is blank. In their quest to keep unnecessary traffic to a minimum, they're saying if you need to work with that, you can call for it, so you'll download it. So it won't send it by default when you log in at the beginning to save airtime. That's giving you, at this point I can change that frequency. If I wish to set up an ad hoc mesh now, I could change that frequency, and all the other devices that need to be on that mesh would change and you operate again. Bandwidth is 250 kilohertz. The spreading factor that's currently being used is 11. Initially, when MeshCore came out, they were using a spread factor of 10, which is twice as fast as spread factor 11. However, it was not as reliable, so we've now settled on spread factor of 11. The way these devices find each other, because there's no automated pings between devices, they send out an advert to announce themselves to the mesh. So you would send out an advert manually. Okay, it sent that advert. Otherwise, you would then send out automated adverts. So you can have a zero-hop advert, which means it will not be repeated by other repeaters. It will only propagate to nearby devices. Or you can have a flood advert. And under flood advert, the minimum time they allow you is once every 3 hours. Again, to not flood the mesh and keep traffic to a minimum. You can set the position. And let's see what it tells us. I have set a position. Hopefully it's going to give us something. Okay, it's picked up the position. And that position is at the German club. I preloaded it beforehand. So it will then show you where it is. Again, I had to request that position from the device. It didn't propagate it out when I originally logged on. Syncing the clock, because these devices don't have real-time clocks in them, they tend to drift. And it's advisable to just update the clock every so often. It's now reset the clock for me, and you can then set passwords. Neighbors. This will show, unfortunately this one, because it hasn't been on the air very long, it doesn't have any neighbors in its list. It shows you all the other repeaters that it can hear on one hop, on zero hop. So it gives you a good overview of the topography of your mesh as to which repeaters can hear each other. Telemetry, it will just give you the battery voltage. If you had other telemetry devices linked to it, that telemetry would also be propagated and delivered on that request. I just wish I could get into this repeater because it has a map that shows the nearby devices. Sorry, just bear with me. I want to just wanting to try and log in and this has been a total failure. I must apologize. Okay, so Werner's been sending us messages backwards and forwards. But if I can just go into the basics of the operation. You as an individual would get a device, you link it to your phone. You, from a companion device, you would send out an advert, because if we each don't have the other station in our address book, you can't communicate. So I would send out an advert. The other station, whoever is interested in communicating with me, would store that advert. He would send an advert, I would see it, and once we've got those adverts, we then communicate. You can also send links by QR code or a text string, which would allow you, if you didn't have a link at that point, to get your address book updated. Then it's simple texting, as we've shown on here. It's backwards and forwards. Initially, the message to the individual station would go out as a flood message until that path is established. And once the path is established, the messages are very, very quick when you've got good repeater coverage. However, if you are mobile, what happens is you move to another area, the path will change. So if you're mobile and you stop to send a message, you need to reset the path to the person you want to talk to, establish a new path, and then you communicate. So it's not meant to be of great flexibility, or not very flexible if you're moving around a lot. I've been testing it a lot in town on my daily drives around, and I stop, reset the path, and then the message goes through. But if you try and send without that, what happens is it will try and use the old path, which obviously in most cases will then be broken because the repeater that it was using is no longer in range, and it will time out and then eventually revert to flood and re-establish the path. So a quicker way is just go in, reset path, not there, but on the individual device, reset the path and re-establish. You have channels. This is the general channel that is available on all the devices, and you can then set up private channels. So if there's 3 of you who want to communicate privately, you'd set up a private channel and it would function like this. No one else would be able to read it. Any questions at this stage before I go in and do a comparison between MeshTastic and MeshCore?
When you set up the private channels, do you share your QR code?
You share a key, yes. Very similar to what you do on MeshTastic. There's a lot of issues that people are picking up around the world that I'm noticing on the chat forums, where people are carrying around. You'll see if you do a little bit of a search, you'll see that there's some very small little personal devices available that less than the size of a cell phone. People are carrying these in their pocket and then wondering why they can't communicate, the network's not working. Unfortunately, we're dealing with very low power. You need a decent antenna. That's the bottom line, unless you've got a very high density of repeaters available. Okay, let's talk about the differences and similarities between MeshCore and MeshTastic, because as you know, I did a presentation earlier on MeshTastic. They both use the same hardware. They both use LoRa as their encoding and method of transmitting the information or carrying the traffic. MeshTastic works on the principle that all devices will forward a message. So every companion that you have, in this case companion there, it's just a node, will forward the message. You also have repeaters in MeshTastic, and they have, in their messaging algorithm, they tend to favor the repeater prior over a individual node. So on the principle that a repeater is normally at a high point with better coverage, so it will send the message first, and a normal private node would send it at a slightly later development, at a slightly later time, milliseconds later. What that means is that message is flying around quite a lot, so there's quite a lot of traffic. In MeshCore, they have specified that only repeaters will repeat, and only repeaters will only repeat on a flood basis until a route is established, and will then retain that route. So if you're working from fixed locations and the route is established, it's very, very efficient and quick because everything else keeps quiet. Whereas on MeshTastic, there's a lot of chatter going on, those messages flying around, and it tends to degrade and lead to less reliability in the messaging, and particularly when it starts scaling up and you have a large number of nodes in the mesh. You also have in Meshtastic nodes, the nodes themselves actually push out information. So they will push out their battery voltage, they will push out their position, temperatures if you've got a environmental sensor attached. From the MeshCore side, that information is also available. However, it's on a demand basis, so you request it. So if I need to know where someone is, I can request their position. So for tracking purposes, if you want to keep a track on someone, Meshtastic is a better method because it's sending out that packet of the information with location at a set interval. Whereas with MeshCore, you can find out where someone is at a point in time. But again, you don't need to know someone's battery voltage every 5 minutes. And this is what a lot of the nodes are doing, is they're sending out voltages at 5-minute intervals. If I need to know repeater's voltage, I log in and I see what the voltage is, and I'm happy it's low, etc. Likewise, the temperature of somewhere. I don't need to know someone's temperature in their home. If I want to know, I will log in and find out. With MeshCore as well, you can restrict who can access that telemetry from your device. You either make it not available at all, you make it available to everyone, or to specific users. So if you want to keep your position private and only allow your wife or your girlfriend to know where you are, you make it available to them only. So it locks down the privacy. I know Meshtastic handled that by allowing you to put in a percentage of inaccuracy into the position so that it would be in a specific location. MeshCore approached it from a slightly different angle. I'm trying to think of other major differences. For me, going from Meshtastic to MeshCore, I wanted a system that is reliable and I can send messages through and I know that I'm getting every message. And I found that MeshCore over Meshtastic gave me that reliability. There is other functionality which Meshtastic has, which is missing here, but for me, MeshCore is what I'm focusing my current endeavors on. Currently, there's a repeater at the university, there's a repeater at Slipper, there's a repeater at my house, there's a repeater at Andrew's house, there is a repeater in Newton Park. And from my experiences of traveling around, that covers most of PE. There's very few areas from my vehicle that I don't get a good signal. The best distance we've done so far with MeshCore was from the university to the top of Suurberg, was 85 kilometers direct line of sight. And from there, the signal was bounced down into a valley where there was a checkpoint for a trail run. And they had communications from there all the way back into Summerstrand. So it proved itself to be quite reliable. Costs, this is the minimum you need. It's a rack board with a battery, and currently when I land them, they're coming in around 900 Rand for that. To that you add an antenna and a case. They work very well on solar power, so repeaters that we have put up on solar work very reliably. Power usage is very low and they work very well. I have boards available if anyone is interested in purchasing one and trying it out. Just let me know and I can pass them on to you. Questions? Mark?
What drew me to Meshtastic many years ago while I started using it was the word mesh,
Yeah.
meaning it's a mesh network, all units repeat. If you take one unit out of the equation, the system still works. Am I understanding it correctly that if I'm at my house and my only path to you is through a unit park repeater, for example, something happens to that repeater, I don't have comms anymore?
That is true, which is why it's important to ensure that your repeater placement and the repeater custodians put them in the correct places, that there is overlap. You need to build that redundancy into it.
So this is a system you would set up for a specific area, for a specific tool, for a specific
Purpose. Yeah.
a specific area, not mobile. You can't quickly move because you need to move the repeaters with you. So if you need to move out of the town.
Okay. Good point. This issue has this issue of companion devices not repeating has been brought up by a number of people, myself and others around the world, with the developers. And their response was that because of their routing, their routing algorithm, if you have a mobile device repeating, the minute it moves, it breaks the route. So your routes are going to be breaking all the time. So they don't promote, and that's why they've gone for static repeaters, because once your routes are established, it then the system works very efficiently. However, they have conceded and are busy implementing a firmware which will allow companion devices to repeat. However, it will force you to move onto a frequency other than what is the regional standard for that region, so that you don't have interference with the core mesh itself. So if you're wanting to set up your own structure with that functionality, where devices will communicate with each other and repeat, you're quite welcome to do it once that firmware is released. However, the frequency would not be the frequency used by the general mesh itself. So you wouldn't then have access to the repeaters that are currently in place. And again, that very first principle of theirs, they want to make sure that the network works well. But if you're wanting to set up and I certainly would want that for our events, for example, where I don't want to have a companion and a repeater sitting next to me. I would want my companion to repeat, and I would then use that firmware in that environment when we go out into the bush, for example. That you don't have to put up set repeaters, everyone would just communicate. So, yes, valid point, but that's the way they would address that and propose to address that issue.
How susceptible is the system to interference? Like alarm, push buttons, vehicle remotes?
Okay. It is being low powered and being in that band where it can be interfered with. Generally around the world, there's very few areas that use 433. We chose 433 because we had some infrastructure available already with antennas up masts, and I also felt that 433 would probably penetrate and propagate a bit better than 868. Around the world, the regions that are using 868 and 915, they're finding that there is a lot more interference at that level because there's a lot more IoT stuff working on those bands. Traffic lights, water meters, and this is specifically places like the UK and Europe. And they're having major problems. They're having to start putting cavity filters into repeaters to try and eliminate interference. Thankfully, we don't have that problem. Because the packet is very quick, and if someone's beeping a car alarm or a gate remote, the chances of there being interference is low. But yes, it could be affected. Although they go right down to well below 14, 16, 18 dB, whatever it is, below the noise floor. Whatever that measurement is, it's up to them to determine what it is. But certainly it goes well below the noise floor, and it's still readable.
So if it doesn't get an acknowledgement that the message was received, does it try again?
It will try 3 times. If it has a root, it will try 3 times. Again, these can be tweaked in the settings, but this is the general default, is it will try and send that message 3 times and it will then fail. Otherwise, you have it set, it will try 3 times and it will then revert to a flood because it thinks the path is broken. And after that attempt, it will then time out until you undelivered. They found that there was quite a few instances where the message was actually being delivered, but the acknowledgement wasn't being received. So to overcome that, they then implemented a double acknowledgement. So the message comes through, there will be an acknowledgement sent, and a short while after, a second acknowledgement will be sent. And they found that that has eliminated a lot of the issues of undelivered messages, because the message is actually getting through, but the ACK is not coming back. But your device will tell you no delivery if it doesn't receive an acknowledgement.
And with Meshtastic, it only sends it once, really.
No, I think it sends it 3 times. It's also a 3 times flood. In a more mobile environment, Meshtastic would probably function better, where you have a lot of activity. But in an urban environment like this, with a well-placed network of repeaters, you can establish a very, very good communication net that works reliably. The other thing you can do is you can set manual path. So you don't have to let it determine a path. You can actually, in the beginning, say, I know that Andrew on the other side over there can hear the slipper repeater. So I will just tell it to send the message via slipper, and it will only send it via slipper, and it'll get through to the other side. So it gives you some flexibility in terms of routing and pathing. One issue that I just picked up recently is that Meshtastic now, in their default settings, are actually turning off their telemetry. So if you update your firmware now, telemetry is turned off. You have to go and turn it on. And that's to try and reduce the amount of traffic and improve the... but unfortunately, I think they've let the cat out the bag there, and people like sending it out. So to get them all to turn it off is going to be a bit difficult. The other problem is you're relying in Meshtastic on all the people updating their firmware. Whereas with MeshCore, as long as your repeater custodians update the repeater firmware, it doesn't matter if your node is old. It doesn't affect me at all. It doesn't affect the net. It doesn't affect the performance of the mesh. So there's pros and cons on both sides, and I'm by no means wanting to start a war between the two schools. It's just for my purposes, I found that MeshCore seems to fit the need of a stable network better. We have a project possibly in the pipeline of linking PE and George up. So that's going to be an interesting one to try and do that. There is no hop limit. Well, there is a theoretical hop limit of 64 hops in MeshCore, whereas I think on Meshtastic there's a 7 hop limit. 3 hops normally, but you can push it to 7. Yeah. With MeshCore, there is no hop. If you set a path, it will keep going.
Apart from maybe using it at events, what would the main reason be for having not MeshCore or Meshtastic system like this? Because it's cool to play with.
Yeah. Look.
It's cool to play with.
Yeah.
I mean,
I see overseas a lot of people who,
which
yeah,
tends to
yeah.
push me to the word emergency communication.
yeah, yeah.
Okay. So if we've got a blackout, if we've got emergency communication, that's what we're looking for.
Yeah.
Something for emergency communication.
Ideally, your repeaters should be solar powered, and because there's not a lot of traffic flying around, I'm finding that with a companion device, for example, you're getting 3-4 days use out of it.
Being a set network, i.e. relying on the repeaters for the network to work. And the biggest main reason or purpose would be for from a blackout emergency communication scenario. Broadening the idea of a blackout, what would happen in a blackout, and living in South Africa and having seen what happened in KwaZulu-Natal, it would not be a safe place necessarily to stay at your house
Yeah.
if a blackout occurs for longer than 2 or 3 days.
Agreed.
Which means you would have to move out of your house for your own safety, which means your network will not be working.
Yes and no. I would have because of doing events, I will have 3 or 4 temporary repeaters available all the time, so you can take them with you. And remember, these devices can still talk to each other. I can't talk to everyone, but I can still talk to you if you're in range of me.
But you need to remember always to find that path.
No, with a companion device, once you're in my address book, that's it. You're in my address book forever. And if you are 5 kilometers away, these devices will talk 5 kilometers quite comfortably without a repeater. Not if it's in your pocket with a decent antenna. So it's just something that needs to be thought through, and the way of using it, yeah. Just for interest, MeshCore's only been in development now for just over 6 months. So they've come a long, long way. A lot of the developers working on it were in fact also working on Meshtastic, and they saw weaknesses or things they didn't particularly like in the way it was working, and they've started this development. Okay, I think we've spoken enough. If people are interested, get hold of me and I can pass on more information. Thank you everyone for listening to me rambling on for hours and hours.